Hey class, this is Mr. Roberts at Shasta High. I wanted to do the last 4 problems with you that appeared in your student textbook. The very last group of questions started with the phrase remember, and then they talked about the addition, subtraction, multiplication, and division properties of equality. It also talked about the distributive property and cumulative and associative properties. And basically these are pretty much the mechanics that we have for solving equations, and I wanted to kind of talk about those in maybe a little bit more high school centric way than you might have thought about them before. The purpose is not to focus so much on what a particular solution is. If I have, for example, the equation x plus 3 equals 10, and I can blink my eyes twice and see that x is clearly the number 7. What's nice to do is to look at this and practice these properties of equality. So one of the things I could do, for example, by the multiplication property of equality, is I could decide I'm going to multiply both sides of this equation by the number 5. Why did I pick 5? I don't know. Is it going to help me solve the equation? No, it'd probably actually make it more difficult to solve. But I can do this, and I can transform this equation using this property of equality. So if I choose to multiply both sides by 5, the left-hand side of the equation becomes 5x plus 15, and on the right-hand side we got 5 times 10, which is 50. So here's the thing. These properties of equalities tell me that if I have equal things, and it gave me that x plus 3 is 10, that's where I'm starting. Assume x plus 3 equals 10, and I multiply by equal things. Well, I multiplied both sides by 5, then it tells me I get equal things. Now I did go on and I used this thing called the distributive property, right? If you look very closely, I distributed this multiplication by 5 across the addition here. But certainly this new expression they're equal because the original expression was equal and I multiplied by equal things. Taking this another step further, if I wanted to, I could add 5 to both sides of this equation. So if I add 5 here and I add 5 here, again I have equal things and I'm going to add equal things, so I get that 5x 15 plus 5 is 20, and that equals the number 55. What else can I do? I have equal things. I'm going to kind of multiply both sides by 2. Why, Mr. Roberts? Well, I know I'm taking the long way home. I'm just convincing myself that I'm skilled at using these properties of equality, and because I'm careful and thoughtful about it, I want to try and gain some confidence. So if I multiply both sides by 2, on the right hand side over here, 55 times 2 should give me 110. And over on the right hand side I'm going to use the distributive property again. 2 times 5x is 10x, and 2 times 20 is plus 40. Well, I know the answer was 7. I knew that at the very beginning. Let's go ahead and wind down and see quickly how we find that, right? So the most direct path from here, where I'm at now, is I'm going to subtract 40 from both sides. I have equal things, I subtract equal things, I will get equal things. The left-hand side is going to become 10 times x, and the right-hand side is going to become 110 minus 40 equals 70. Final step, since these are equal things, and I can divide by non-zero equal things, 10x over 10 equals 70, therefore x must be the number 7. Now, this solution, right, x is 7, if it is a solution, it will satisfy this equation, it'll satisfy this equation, it'll satisfy this equation, and of course it'll satisfy the original equation. Because I'm applying the properties of equality to this original expression, everything that I get along the way has to be equal to the things before it. So I'm going to go ahead and check this answer, and I like to check my answers using this kind of pretty overly organized method. But I'm writing the left-hand side of my original equation up here on the left, and I'm writing the right-hand side of my original equation up here on the right, and then I'm just going to do a substitution. If x is 7, I've got 7 plus 3. 7 plus 3 is 10. and over on the right hand side I have 10. So sometimes it'll take more steps to get there, but I can see that I have 10 and 10 on both the left and the right hand side. So x equals 7 is a valid solution. Let's take a look at a couple more problems. It says solve in your book. It says solve each equation and justify your reasoning. So I'm going to begin by applying the subtraction property of equality. If I have equal things and I subtract equal things, then I get equal things. So this becomes 7x equals negative 14. Next, I'm going to apply the division property of equality and divide both sides by 7. If I have equal things and I divide by equal things, then I get equal things, as long as it's not 0. On the left-hand side, I have a common factor of 7, and factors can be canceled. Right? So be very careful, though. They are factors, meaning I've got multiplication. 7 times x in the numerator produces the product 7x. My denominator is 7 times 1. Right? So you can think about that 1 factor being there. So on the left-hand side now, I'm left with just x, and on the right-hand side, I have negative 2. So this is my proposed solution, and I check this solution. Same way, I'm going to write 7x plus 2, and I'm going to be making a comparison with the negative 12. 7 times negative 2 plus 2. 7 times negative 2 is negative 14 plus 2, and negative 14 plus 2 is negative 12. And again, I can see on the right hand side it's also negative 12. So this is the solution, and the solution checks. Let's try question B. I could use the distributive property if I wanted to, but I think I'm not going to. I think I'm going to use the division property of equality and take care of this 4 in a minute. I'm going to begin by using the subtraction property of equality. Subtract 12 from both sides. My left-hand side then becomes 4 times the quantity of x minus 7, and it is x plus negative 7. I'm choosing to write it as x plus or x minus 7. And over here I have that equals 20 minus 12, which is 8. Next, I'm going to divide both sides of this equation by 2. So you can see we've used subtraction property of equality and now division property of equality. I have a common factor of 2, right? 4 is 2 times 2, and I've got 2 times 2 times x minus 7. So I'm going to cancel out a factor of 2 for my denominator and numerator, and I am left with 2. Now why did I choose to divide by? Why did I choose to divide by 2? I should have divided by 4. Let me go back and change that. A lot of you are sitting like, yeah, he's doing crazy stuff. I don't know, maybe he wanted to do that. Well, maybe I wanted to, but the most direct solution path would be to divide both sides by 4. Now I'm going to cancel this common factor of 4, and I'm left with x minus 7, and over here that's going to equal 2. And then to finish this off, we'll apply the addition property of equality and add 7 to both sides, and I get that x equals the number 9. Again, to check this, yeah, I have enough room to check it here. I'm going to have 4 times the quantity of 9 minus 7 plus 12, and I'll be comparing that with the number 20. 9 minus 7 is 2, so this is going to be 4 times 2 plus 12. 4 times 2 is 8, 8 plus 12, and 8 plus 12 is 20. So you can see I get 20 on the left-hand side and 20 on the right-hand side. So indeed, the solution is x equals 9. Last 2 questions. These are great because all of a sudden I'm not going to get ridiculously easy or predictable answers or integer answers. So this is kind of tough. The first thing that I'm going to choose to do is I'm going to add 13 to both sides. So I have equal things. I'm adding equal things so that I'm sure I'm going to get equal things. On the left hand side I have 14x, and on the right hand side this must be exactly 9x plus 14. And now I'm going to choose to subtract 9x from both sides. If you have equal things and you subtract equal things, and you get equal things. 14 minus 9 is 5x, and over on the other side I have that 9x minus 9x is 0, so I'm left with the 14. So I get this interesting situation, right? When I divide both sides by 5, I get that x must be 14/5. And that is not the kind of answer that a lot of us are conditioned to seeing in a traditional high school textbook. You know, it's a rational number, and it's a little bit more involved. I'm going to verify this answer, and this one I'm going to do. I'll go ahead and go for this one. I'll do the next one in a more simplistic way. But I'm going to go ahead and write, I've got 14, and I got to multiply that by 14 times 5. And I'm going to subtract 13 from that. And that has to be the same as, so this has to be the same as 9 times 14/5 plus 1. I think I have enough room on this page for this. So 14 times 14, 14 over 1 times 14 is going to be 14 to the second power over 5. And if I look at this 13/5, I'm going to change, or 13 rather, I'm going to change that to 13/5 by taking the number 13 and multiplying it by 5. So I get 65/13, so minus 65/13. So if you look at this, I now have, because I changed, this is equal to 13, 65/13. No, not 65/13, it's 65/5. If I take 65 and divide it by 5, I get exactly negative 13. The reason why I did this was I wanted to have a common denominator. So now I can combine these two. So on this side I'm going to take 14 and I'm going to square that. And I'm going to take and subtract 65, and I get 131 over 5. 131 over the number 5. I'm going to leave that for a minute and go to the right hand side. The right hand side I'm going to have 9 times 14 over 5, and I'm going to compare that to 5/5. That's equal to 1. So I'm going to go ahead and evaluate that if this is all over one fraction. So 9 times 14 plus 5. 9 times 14 plus 5. And when I evaluate that, I also get 131/5. So because the right hand and the left hand side are equal to each other, this is indeed our solution. Last one up here, this is a proportion, and there's certainly ways for dealing with proportions that are beyond our basic properties of equality, but I'm just going to limit ourselves to the properties of equality, and I'm going to multiply both sides of this equation by 6 first of all, because if I have equal things and I multiply by equal things, I get equal things. When I do that, over here on the left hand side, you can see I've got something, this x plus 2 is being multiplied by 6, and this 1's being multiplied by 6. Since this is indeed multiplication of 6 times this value, I can cancel this common factor. And that's why I chose to multiply by 6, because I knew it would eliminate this denominator. Up in my numerator, I have an x plus 2 left over, and that's going to equal 2 times 6 over 5. 2 times 6 is 12 over 5 is 5. I'm going to clear this fraction also. I'm going to go ahead and do this and multiply both sides by the number 5. I can probably do this a different way, but I like this. So I multiply by the 6, now I'm multiplying by 5. On the right hand side, if I have 12 divided by 5 and then I multiply by 5, of course this is just 12. And I'm going to apply the distributive property now. On the left hand side I get 5x and plus 10. So let's apply the subtraction property of equality. We get that 5x is equal to 12 minus 10 is 2, and therefore x must equal 2/5. I'm going to verify this using my calculator. So I'm just going to take my calculator, I'm going to enter x plus 2 over 6, and I'm going to compare that with the number 2/5. So when I do it on the left hand side, again, I'm going to take 2 divided by 5, press equals, that gives me 0.4. I'm going to add 2 to that, and then I'm going to take that value and I'm going to divide by 6. When I do that, I get the number 0.4. Over on the right hand side, when I take 2 divided by 5, I'm like, oh yeah, 2/5 is the same thing as 4/10, isn't it? So since the left and the right hand side are the same, I know this is a solution.